To run a branch circuit to a garage underground in Conduit, it's important to follow the National Electrical Code, or NEC, guidelines. When installing underground conduit, firstly, consider the type of conduit. Use Schedule 40 polyvinyl chloride, or PVC, or Schedule 80 rigid non-metallic conduit, or RNMC. Secondly, consider the size. The conduit size must be large enough to accommodate the wires and any future additions. For a 200-foot run, a minimum 1-inch conduit is recommended. Thirdly, the depth. Bury the conduit at least 18 inches deep for protection from damage. Fourthly, consider the slope. Provide a slope of at least 1/4 inch per foot to prevent water accumulation. Fifthly, conduit fittings. Use sweeps and bends to avoid sharp angles. And lastly, wire type. Use thermoplastic high heat resistant nylon coated wire, or THWN, thermoplastic high heat resistant nylon coated wire, or THHN, or cross-linked polyethylene high heat resistant wire, or XHHW, for the branch circuit wire. When installing the conduit underground, 1. Plan the route and mark the location of the conduit. 2. Excavate a trench for the conduit, ensuring it meets the depth and slope requirements. 3. Lay down a layer of sand at the bottom of the trench. 4. Install the conduit, using sweeps and bends as needed. 5. Secure the conduit with conduit bodies and straps. 6. Fill the trench with sand or sifted topsoil and compact it around the conduit. It is beneficial to use a direct burial wire rated for underground use if possible. Consider installing a surge protector in the garage to protect equipment from electrical surges. Obtain a permit and have the work inspected by a qualified electrician to ensure compliance with local codes. Ensuring proper electrical work requires careful attention to detail and adherence to safety standards. When planning an underground conduit installation for a branch circuit to a garage, several factors must be considered to guarantee safety and compliance with electrical codes. The National Electrical Code, or NEC, provides comprehensive guidelines that cover the materials, installation techniques, and safety measures necessary for such projects. Understanding and following these guidelines is crucial for a successful and safe electrical installation. The selection of the appropriate type of conduit is the first important step. Schedule 40 polyvinyl chloride, or PVC, and Schedule 80 rigid non-metallic conduit, or RNMC, are commonly recommended for underground applications due to their durability and resistance to corrosion. These materials are designed to withstand the harsh conditions present in underground environments, including moisture, soil chemicals, and physical stress. Schedule 40 PVC is suitable for most residential applications, while Schedule 80 RNMC offers additional protection against physical damage, making it a better choice for areas where the conduit might be exposed to heavy loads or potential impact. Determining the correct conduit size is equally important. The conduit must be large enough to accommodate the wires required for the branch circuit and any future additions. Overcrowding the conduit can lead to overheating and insulation damage, increasing the risk of electrical hazards. For a 200-foot run, a minimum 1-inch conduit is generally recommended. However, it is essential to calculate the fill ratio based on the number and size of the conductors to ensure compliance with the NEC. The fill ratio refers to the percentage of the conduit's cross-sectional area that is occupied by the conductors. The NEC specifies maximum fill ratios to prevent overheating and facilitate wire pulley. Burying the conduit at the correct depth is crucial for protecting it from physical damage. The NEC requires a minimum burial depth of 18 inches for residential branch circuits. This depth provides adequate protection against damage from digging, landscaping activities, and other potential hazards. In areas with heavy traffic or where the soil is particularly rocky, a greater burial depth may be necessary to ensure the conduit's integrity. Maintaining a proper slope is essential to prevent water accumulation inside the conduit. A slope of at least 1/4 inch per foot allows water to drain away from the electrical components, reducing the risk of corrosion and electrical faults. Without proper drainage, water can collect in the conduit, leading to deterioration of the wires and potential safety hazards. Using appropriate conduit fittings is vital for creating a secure and reliable electrical pathway. Sweeps and bends should be used instead of sharp angles to minimize stress on the wires and facilitate easier wire pulling. Sharp angles can damage the insulation of the wires, leading to shorts and other electrical problems. Conduit buttons and straps should be used to securely fasten the conduit to ensure it remains in place and protected. Selecting the right type of wire is critical for underground applications. Thermoplastic high heat resistant nylon coated wire, or THWN, thermoplastic high heat resistant nylon coated wire, or THHN, and cross-linked polyethylene high heat resistant wire, or XHHW, are commonly used for branch circuits. These wires are designed to withstand the harsh conditions of underground environments, including moisture and temperature variations. THWN and THHN wires have a nylon coating that provides additional protection against abrasion and chemicals, while the XHHW wires offer excellent resistance to moisture and heat. Following a systematic approach to installing the conduit underground is essential for a successful project. The first step is to plan the route and mark the location of the conduit. This involves considering the layout of the property, the location of the garage, and any potential obstacles such as trees, fences, or underground utilities. Marking the route clearly will help ensure that the trench is dug in the correct location and that the conduit is installed according to the plan. Excavating a trench for the conduit is the next step. The trench should be deep enough to meet the minimum burial depth requirements and wide enough to allow for easy installation of the conduit. The sides of the trench should be sloped or shored to prevent collapse, especially in unstable soil conditions. It is crucial to ensure that the trench is safe to work in before proceeding with the installation. Laying down a layer of sand at the bottom of the trench provides a smooth and protective bed for the conduit. The sand helps to prevent damage to the conduit from rocks or other sharp objects in the soil. It also helps to distribute the load evenly along the conduit, reducing the risk of stress or breakage. Installing the conduit involves carefully placing it in a trench and connecting the sections using appropriate fittings. Sweeps and bends should be used to navigate around obstacles and to change direction smoothly. The conduit should be aligned properly and securely fastened to ensure it remains in place. Backfilling the trench with sand or sifted topsoil and compacting it around the conduit provides additional protection and support. The sand or topsoil should be free of rocks or other sharp objects that could damage the conduit. Compacting the soil helps to prevent settling and ensures that the conduit remains at the correct depth. In addition to these basic steps, there are several other considerations that can help ensure a successful underground conduit installation. Using a direct burial wire rated for underground use is highly recommended. Direct burial wires are specifically designed to withstand the harsh conditions of underground environments, including moisture, chemicals, and physical stress. They are typically made with a thicker insulation and a more durable jacket than standard wires, providing additional protection against damage. Installing a surge protector in the garage can help protect your equipment from electrical surges. Surges can occur due to lightning strikes, power outages, or other electrical disturbances. A surge protector can help to divert excess voltage away from your equipment, preventing damage to sensitive electronic components. Obtaining a permit and having the work inspected by a qualified electrician is essential for ensuring compliance with local codes. Electrical codes are designed to protect people and property from electrical hazards. A qualified electrician can ensure that the installation meets all applicable codes and that it is safe to use. The inspection process helps to identify any potential problems and ensures that they are corrected before the installation is put into service. By following these guidelines and taking the necessary precautions, it is possible to safely and effectively run a branch circuit to a garage using underground conduit. This will provide a reliable and safe source of power for your garage, allowing you to use it for a variety of purposes. Always prioritize safety and consult with a qualified electrician if you have any questions or concerns. Electrical safety is paramount when working with any electrical system. Before starting any electrical work, it is essential to disconnect the power supply to the circuit you will be working on. This can be done by turning off the circuit breaker or removing the fuse that supplies power to the circuit. It is also important to use insulated tools and to wear appropriate personal protective equipment such as gloves and safety glasses. Never work on electrical systems in wet or damp conditions, as this increases the risk of electric shock. If you are not comfortable working with electrical systems, it is best to hire a qualified electrician to do the work for you. The complexities of electrical installations often require a deep understanding of electrical theory, wiring techniques, and safety protocols. Improperly installed electrical systems can pose significant risks, including fire, electric shock, and equipment damage. Therefore, it is crucial to approach electrical work with caution and to seek professional assistance when needed. In addition to the specific steps outlined above, there are several other factors to consider when planning and executing an underground conduit installation. The type of soil in the area can affect the choice of conduit and the burial depth. Sandy soils are generally easier to work with and provide better drainage, while clay soils can be more difficult to excavate and may require additional drainage measures. Rocky soils can pose a challenge to digging and may require the use of specialized equipment. The presence of underground utilities must also be considered. Before digging, it is essential to contact the local utility companies to locate any underground cables, pipes, or other facilities. Digging near underground utilities can be dangerous and can result in damage to the utilities, service disruptions, or even injury. The climate in the area can also affect the installation. In areas with cold winters, the conduit may need to be buried deeper to protect it from freezing temperatures. In areas with hot summers, the conduit may need to be shaded or insulated to prevent overheating. The local building codes and regulations must be followed. These codes and regulations are designed to ensure that electrical installations are safe and compliant with industry standards. It is important to obtain the necessary permits and to have the work inspected by a qualified inspector to ensure compliance. When selecting materials for the installation, it is important to choose high-quality products that are designed for the intended use. The conduit, wires, fittings, and other components should be UL listed or certified by a recognized testing laboratory. This ensures that the products have been tested and meet the applicable safety standards. It is also important to use the correct size and type of wire for the branch circuit. The wire size must be adequate to carry the expected load without overheating. The wire type must be suitable for the environmental conditions such as moisture and temperature. The connections between the wires and the electrical devices must be made properly. Loose or corroded connections can cause overheating and electrical hazards. The connections should be clean, tight, and protected from moisture. The electrical devices, such as outlets, switches, and lighting fixtures, must be installed correctly. The devices should be securely mounted and properly grounded. The wiring should be neat and organized, and all exposed wires should be protected. The installation should be tested to ensure that it is working properly. The voltage, current, and resistance should be measured to verify that the circuit is operating within the acceptable limits. The grounding system should be tested to ensure that it is effective in protecting against electrical shock. By following these guidelines and taking the necessary precautions, it is possible to safely and effectively run a branch circuit to a garage using underground conduit. This will provide a reliable and safe source of power for your garage, allowing you to use it for a variety of purposes. Remember to always prioritize safety and consult with a qualified electrician if you have any questions or concerns. The installation of an underground conduit system for a garage branch circuit is a significant undertaking that requires careful planning, precise execution, and a thorough understanding of electrical codes and safety practices. By adhering to the guidelines outlined in the National Electrical Code, or NEC, and employing best practices for material selection, installation techniques, and safety protocols, it is possible to create a reliable and safe electrical system that will serve the needs of the garage for years to come. The process begins with a comprehensive assessment of the site and the electrical requirements of the garage. This includes determining the location of the garage, the distance from the main electrical panel, the types of electrical loads that will be used in the garage, and any potential obstacles or environmental factors that may affect the installation. Once the site assessment is complete, a detailed plan should be developed that outlines the route of the conduit, the type and size of materials to be used, the installation techniques to be employed, and the safety precautions to be taken. The plan should be reviewed by a qualified electrician to ensure that it meets all applicable codes and regulations. The selection of the appropriate type and size of conduit is critical for ensuring the long-term reliability and safety of the electrical system. Schedule 40 polyvinyl chloride, or PVC, conduit is a popular choice for underground applications due to its durability, resistance to corrosion, and ease of installation. Schedule 80 rigid non-metallic conduit, or RNMC, offers enhanced protection against physical damage and is recommended for areas where the conduit may be exposed to heavy loads or potential impacts. The size of the conduit must be sufficient to accommodate the wires required for the branch circuit, as well as any future additions or modifications. Overcrowding the conduit can lead to overheating, insulation damage, and increased risk of electrical hazards. The depth at which the conduit is buried is also an important consideration. The NEC requires a minimum burial depth of 18 inches for residential branch circuits to protect the conduit from physical damage and to minimize the risk of accidental contact with underground utilities. In areas with heavy traffic or rocky soil, a greater burial depth may be necessary. Proper drainage is essential to prevent water from accumulating inside the conduit. A slope of at least 1/4 inch per foot should be maintained to allow water to drain away from the electrical components. Conduit fittings, such as sweeps and bends, should be used to avoid sharp angles and to facilitate easier wire pulling. Sharp angles can damage the insulation of the wires and increase the risk of shorts or other electrical problems. The selection of the appropriate type of wire is also critical for ensuring the safety and reliability of the electrical system. Thermoplastic high heat resistant nylon coated wire, or THWN, thermoplastic high heat resistant nylon coated wire, or THHN, and cross-linked polyethylene high heat resistant wire, or XHHW, are commonly used for branch circuits. These wires are designed to withstand the harsh conditions of underground environments, including moisture, temperature variations, and exposure to chemicals. The wires should be sized appropriately to carry the expected load without overheating. The installation process should be carried out in a systematic and organized manner. The first step is to excavate a trench along the planned route of the conduit. The trench should be wide enough to allow for easy installation of the conduit and deep enough to meet the minimum burial depth requirements. The bottom of the trench should be leveled and compacted to provide a stable base for the conduit. A layer of sand should be placed at the bottom of the trench to protect the conduit from rocks or other sharp objects in the soil. The conduit should be carefully placed in the trench and connected using appropriate fittings. Sweeps and bends should be used to navigate around obstacles and to change direction smoothly. The conduit should be aligned properly and securely fastened to ensure that it remains in place. Once the conduit is installed, the trench should be backfilled with sand or sifted topsoil. The soil should be compacted around the conduit to provide additional support and protection. The backfilling process should be carried out in layers to prevent damage to the conduit. After the trench is backfilled, the wires should be pulled through the conduit. This should be done carefully to avoid damaging the insulation of the wires. A wire lubricant can be used to make the pulling process easier. The wires should be connected to the electrical devices in the garage according to the wiring diagram. All connections should be clean, tight, and secure. The electrical devices should be properly grounded to protect against electrical shock. Once the wiring is complete, the electrical system should be tested to ensure that it is working properly. The voltage, current, and resistance should be measured to verify that the circuit is operating within the acceptable limits. The grounding system should be tested to ensure that it is effective in protecting against electrical shock. Finally, the installation should be inspected by a qualified electrical inspector to ensure that it meets all applicable codes and regulations. The inspector will verify that the materials used are approved, that the installation techniques are correct, and that the electrical system is safe to operate. By following these guidelines and taking the necessary precautions, it is possible to safely and effectively run a branch circuit to a garage using underground conduit. This will provide a reliable and safe source of power for your garage, allowing you to use it for a variety of purposes. Always prioritize safety and consult with a qualified electrician if you have any questions or concerns.